Hello everyone. Today I am going to discuss. I have already discussed in last lecture about Fibonacci heap, but last time we have left some topics. See, all these slides we have discussed last time. We have discussed insertion, extract minimum key, and we have already covered all these things in decrease key. I have completed this using algorithm. Now, one thing which is left, that is the union. In the union, we have different two heaps like this heap H dash and heap H double dash. We have these two heaps in which we have combination of trees. See, in the union, we just simply need to combine two Fibonacci heap. See, in this Fibonacci heap, this node is minimum, and in this Fibonacci heap, this node is minimum. We just need to combine it. So what we need to do is we need to combine it. Representation is like root list R circular doubly linked list. See, you can see this is the circular doubly linked list. See, 23 is linked with this node 24, and this 24 is also linked with this 23. So this is a circular doubly linked list. See, we just combine this 17 node with 7. In this, we just need a link in these two nodes, right? See, we just make a union, make a combination with these two nodes. See, now which one, after combination of these two heaps, we just need to recognize the minimum key. In the all root list, only this one is the minimum key 3. So we make a pointer towards this node. So this is how we make union into the Fibonacci heap, which is very simple, right? Now the last one is delete. How do we delete the Fibonacci heap? We need to follow these 3 steps. First, we have to delete node, which we need to delete. Then decrease key, what we have already explained in last lecture. You can follow this PPT. And the last one is extract minimum element in heap. If you follow these, we have already discussed about this. We have already discussed, so you can follow this, okay, and follow these 3 steps. We can delete any node from the given heap, right? So basically today I am going to discuss about the next complex topic of convex hull, which is from your third unit in AKGEC syllabus of design and analysis of algorithm, right? Convex hull, basically convex hull is a polygon. We find out the polygon from a plane where we have lots of set of points and we need to draw a polygon, right? As you can see here, a polygon P is a convex if for every pair of points x and y in P, the line xy in P, the line xy is also in P, otherwise it is called concave, right? See, this is the polygon surface. If you draw a line from x to y, which is lie within this polygon, means that is the convex. And here also x point is lie in the polygon and y is also lie in y line point is also lying in the in this polygon, but the line between the x and y is not, the line between the x and y is not completely into the polygon, that means it is a concave. So this is the difference between concave and convex. See, I hope this is clear to you. Next is a convex hull problem. Basically, in the convex hull problem, we have a set of planar points. Like we have these planars. In this planar, we have lots of points. So by using the algorithm, we have to find out these polygon points and make a polygon. That's it. This is the polygon, convex polygon containing all the points within the polygon, right? So this is the convex hull problem, and we used to solve this problem by using various algorithm, in which very popular algorithm is Graham-Scan algorithm. And in this algorithm, basically we have P naught point into the Q. Q can be any surface or plane, in which it has minimum y coordinates, right? Second point is we have lots of points into the plane, so all the points be the remaining points in Q, right, sorted by polar angle in counterclockwise order around P naught. We will going to discuss about these points. Let me explain just this algo simply, right? In the third step, what we are going to do, push the P naught point. We just need to point 3 points and push that into the stack. We use stack for this algorithm, in which we need to push points, and then in a particular condition we have to pop that points, and through by following these points we are going to make polygon, right? See, for I to 3, first 3 points we have to push into the stack. For the rest of the points, what we are going to do, if the points lie to the right side of that point, then we have to pop, otherwise we have to push, right? And then we return the stack values. Okay, so this is very simple algo we are going to discuss. See, like in the this is the example of Graham-Scan. See, these are this in this plane we have these points, and we have to make a polygon over here, which has to be a convex hull, right? So basically we just need to find out the points over there. The first point is this, second point is this. I am going to take this as a plane here, right? When I take this, it is as a plane here. See, we can mark it as a 0, 0 to 1, right? 0 to 1 in a stack. I push P0 as marked in the as written in the algo. Next is your P point 1, and then next is 2. We have to enter these 3 points into the stack. What is for the next point? See, if in the stack now we have 0, 1, 2, right? 0, 1, 0, 1. If I extend this point, then this must be your right side and this must be your left side. If the point is lie to the left side, then I push the point over here 2. So I marked it as a marked it with a green color, right? So according to the algorithm, I marked it, okay, from 1 to 2. Next is now in the 0, 1, 2. When I am here on this point, I am going always counterclockwise, right? Counterclockwise means I am taking points from this point, right? Like this, from 1, 2, 3, 4, 5, 6. Okay, that's why I marked all these points with the blue color, right? So I am going like this way, okay, counterclockwise. Now this next point is 2. If I extend this point is right and this point is left. When the point lie into the left side, then I push into the stack. So I push this 3 point into this stack, right? So at the first if I enter this point and this point, next what I do, extend this point, this lie 2 lie into the left side, so I push 2 into the stack. This is my stack. Okay, now when I am at the point 2, okay, I extend this point and try to find out the left side point, which is 3. Okay, this is lie into the 3, okay, into the left side, third point. So I entered this point. Now my top of stack is 3, right? Now next, when I go counterclockwise, next point is your 4th point. See, now again 0, 1, 2. Okay, I have already insert this point into the stack, right? If I extend this point, this part is right and this part is left. Whenever a point if any point is lie into the left side, then I push that point. So 4th point, it should be pushed it here, right? Now your top of the stack is 4. I hope this is clear to you all, right? Next, if I go counterclockwise, next point is 5. So see, as I entered 0, 1, 2, 3 and 4, right? If I extend this, third point, if you extend, it lies out there. If you extend this, see, 4th point, 1, 2, 3, 4. Now see, if you extend this point from this 4th point, this one is your right, let me erase this point. See, now this is your right side and this is your left side. According to the algo, see, if it is right, non-left turn is right, then you have to push, otherwise you have to pop, otherwise push. See, in this point, if you right side, left side, this it should be, I think, see, I pop 0, 1, 2, 3, 4 over here. Now if I extend this point is right, this part is your right and this part is your left. Okay, if I extend this part, so if any point lie into the right side, okay, if see, if any point is lie into the right side, what we have to do, we have to pop. Okay, now top of the stack is your 4, you need to pop 4 from here, right? If you pop, see, we in the last slide we make a line, green line from 3 to 4, but here this point is lie right side. Okay, so whatever on the top of the stack we have to pop it. Okay, we have to pop it. So see, now we check from this point again, 0 1 2 3, and we pop 4 from the stack. Now your top of stack is 3. See, if you check this point, this part is your right and this part is your left. Again there is a problem. Okay, this part is right and this part is left, yani this point is lie onto the right side, so we have to pop 3 from there. Okay, because of this we have to pop 3. Okay, now you can see in the previous slide I have a connection from 2 to 3, but now we need to pop it. So your connection is from, see, 0 1 2 3 and 4 you pop, right? See, if you extend this point, this part is your right and this part is your left, means no issues. 5 is lie onto the left side. See, now you have to push 5 here. When you push 5 here, see, when you are on this point, if you extend this point, this part is your right and this part is your left. Now at the left side you have this point 6, right? Now you can push 6 into the stack, and this is your top of the stack, right? Now next point is 6. If you extend this point, right, let me make it clear, more clear to you. See, if I extend this line, so this part is your right and this part is your left. Whenever you whenever a point is at right side, you have to push, right? So on the top of stack we have 6 over here. Now 0 1 2 5 6, right? 6, I have to pop 6. I have to pop 6 from there, from the top of stack, right? If I pop 6, now I am at 5. Now my top of stack is 5, and I am standing on this point. From this point, again this is on the right side of this point, right side of this plane. This part is your right and this part is your left, right? So again I have to pop 5 from here. So now I pop 5 and 6. Okay, 0 1 2, these 3 points into my stack, right? And I pop 5 and 6 from the stack. Again I am on the 2. Again, when I am standing on this point, I extend this point like this. Okay, the extension is like this. Now this part is your right side and this part is your on the left side. If your point is lie into the left side of the plane, right, so you have to push that point. Now you have to push this point here. See, so I extend, I push 7 into the stack. Now my connection is from 0 1 to 7. right? Now it means, see, this is my basic initial point. 0 1 is my plane and initial point, and I move counterclockwise every time whenever a point line into the right side. So I need to push and go back to the point, push the point from the stack and go back to the uh, see, like this. If I likewise this, I am on the 6th point, right? If a point lie on the right side, I have to pop. See, I have to pop. Okay, now my top of stack is uh, the points which is below from that top of stack, right? Now I am back to the point. If a point lie again, so on the right side, like 7 is on the right side, so again I have to push that point. If my point is lie into the left side, okay, if my point is lie into the left side, I do not need to pop, I just need to push the point into the stack, and the remaining points into the stack in the last, that is the points which make a good polygon into the plane, right? Likewise in this plane we have these certain points in which 0 1 is my plane. I go counterwise, so when I go counterwise, 0 1 2 7 makes a good polygon into this plane. See, and all the remaining points on the remaining points of the plane are within this polygon. Means this is the algorithm through which, Graham-Scan algorithm, through which we can find out the convex hull. Okay, find out the convex hull, in which we find out the polygon and all the points within that polygon, right? This is the way we uh, get solution from the Graham-Scan algorithm. So Graham-Scan algorithm, it gives you basically a order of n log n due to initial sort of angles. Okay, every time we make an angle, we find out the left and right side. Okay, so we get n log n, order of n log n complexity. See, the next one is convex hull by divide and conquer. You can use any one. You can use Graham-Scan or you can use convex hull. First, in the convex hull, you have to sort all the points by their x coordinates. Okay, as mentioned in this slide. Then, in divide and conquer, you have a complete set of polygon plane. Okay, you just need to find out the convex hull of the left half. You have to divide that plane and find out the convex hull of the left half and find out the convex hull of the right half, and then you have to merge that hull into the one. This is the way how you can find out convex hull or set of or a polygon into the plane using divide and conquer. Okay, let's say this is the example. Okay, if I take it as P naught and take it as Pn, okay, what I need to do, I just need to partition, divide that plane. This is a complete one plane, I just need to divide that plane. I simply draw a line over there. Okay, I divide this plane. Now see, this is my P1. I make a line here, P2. Okay, this is the triangle. This is making a triangle over here. If this kind of condition is occurring, then what I need to do, I just need to connect P0, P2 directly. So I remove this part. Okay, this is not part of my polygon, right? When again I am going, let's say, see, Now if I'm taking, now this part is C P naught, I may mark it as P1, P2 and P3. If I connect these points, I can say if I connect this point, it make a triangle over here. So what I do, I just make a simple line. I just make a this makes a triangle here. Okay, whenever this condition is occurring, so what I will do, I just make a single line between the P1 and P3. This triangle, I just remove this part and this part. Okay, this makes a polygon here. Again, see, if I connect this point, now I marked it as P2, right? If this is P2, P3 and Pn, right? I am just taking the upper half of the plane and find out the convex hull, right? If you observe, it makes a triangle over here. If this condition is arises, then you have to just need to remove these points from here. Okay, now it means this makes a upper up. You have already solved this part of the plane. Now you have to solve lower part of this plane. So how you will going to solve? See, if you check P naught, P naught, P4 and P5, and triangle is making, okay. If this condition arises, you have just simply need to delete this part. Okay, delete this part. Now see, P4, this part is your P4 now. Okay, if you connect these points P4, P5 and P6, okay, a triangle is occurring here. So you just need to delete this point. You just need to delete these points and make a line over here. Okay, fine. See, last, if you make here, if you see, this is also a condition of your triangle. You have to cut this part and just take a single line here. Okay, in this way you have to connect this part is a P5, P6 and P7. So this is how you find out the convex hull into the lower part of your plane, and this is the way how you can find out convex hull using divide and conquer. You just need to split, okay, into the upper and lower half, and then after solving the convex hull you need to merge this. One more thing, if you find out a point onto the same lane, okay, let's say these are my points, if lie onto the same line, so you have to consider this is the angle, this one is angle and this one is angle. You have to take the angle which one is greater. Okay, this one is greater, so you have to pick this point only. Okay, this is the way you can solve convex hull problem using the divide and conquer method. So in today's lecture we discuss convex hull using gram scan and divide and conquer approach, right? Thank you.